Hi everyone. In today's session, we'll see the DC response of RLC circuit. So coming to the circuit diagram, DC supply voltage is connected through the switch S to series RLC circuit. The response is current. We need to find out the current response. Initially, we are assuming that the inductor and capacitor are initially uncharged. And when the switch S is closed at t is equal to 0, we can determine the complete solution of this current. If switch is closed means it will become short circuit, then we can determine the complete current solution. As the first step, what do you do? We have to apply the KVL to this circuit when the switch is closed at t is equal to 0. So V is equal to R into I plus voltage across inductance is L into di by dt, capacitance is 1 by C integral I into dt. By differentiating the above equation on both sides, we can get differentiation of constant voltage V is equal to 0, R into di by dt plus L into d square I by dt square plus differentiation of integration is nothing but only I, that is I by C. I can rewrite the same equation by dividing on both sides with L, d square I by dt square plus R by L into di by dt plus 1 by LC into I is equal to 0. So if you see the above equation is a second order linear differential equation, with only complementary function. We'll get the solution, and the particular solution is 0. We'll see how we get. Out of this, I can write the d by dt as d for further simplification. So here capital D is equal to d by dt. So d square into I, R by L into di plus 1 by LC into I, that I can write it as d square by taking that I common, d square plus R by L into d plus 1 by LC into I is equal to 0. So out of this equation, this d square plus R by L into d plus 1 by LC is called as characteristic equation is equal to 0. For that, we can find out the roots. The roots are d1 and d2. If we compare this equation with ax square plus bx plus c, the roots of that ax square plus bx plus c is nothing but minus b plus or minus under root of b square minus 4ac by 2a. Out of that, we'll get the roots as minus r by 2l plus or minus under root of r by 2l square minus 1 by lc. If these two will go to the numerator and into that square root. For further simplification, here I am assuming the first term as k1 is equal to minus r by 2l, second term as k2 is equal to under root of r by 2l square minus 1 by lc. So what are the roots now in terms of k1 and k2? k1 plus or minus k2. That only I have written here. d1 is equal to k1 plus k2, dt is equal to k1 minus k2. If out of these roots, if you observe the k2 equation, this k2 may be positive if r by 2l square is greater than 1 by lc. It can be negative if it is less than 1 by lc. It can be 0 if both are same. Both the terms are same. R by 2l square is equal to 1 by lc. So we will get the three cases. In case 1, if k2 is positive means r by 2l square is greater than 1 by lc. k2 is positive when r by 2l square is greater than 1 by lc. If it is the case, then the roots are real and unequal. The roots can be real and unequal like this, and it gives a overdamped response as shown in the figure. We'll see the figure. Then the equation 1 is nothing but this one, right? Equation 1 becomes, we got the roots as k1 plus k2 and k1 minus k2 when k2 is positive, right? So that only I can write it as d minus of first root, d minus of second root, d minus of k1 plus k2 into d minus of k1 minus k2 into I is equal to 0. The solution for this equation, is nothing but I is equal to c1 into e power first root into t plus c2 into e power second root into t. c1 e power k1 plus k2 into t plus c2 into e power k1 minus k2 into t. The overdamped response on y-axis if you take current and x-axis if you take time, it will take long time to reach the steady state. It will increase, start from 0, it will increase and it will go to the 0 again in the steady state, but it will take longer time. So that's what the current response. In the second case, if K2 is negative, K2 is negative means the K2 R by 2L square is less than 1 by LC. Less than 1 by LC. If you do like that, then under the square root you will get the negative term. Because of that, you will get the complex conjugate roots. The roots are complex conjugate and gives the underdamped response as shown in the figure. We'll see that figure. So I can rewrite the same complex conjugate roots. What are the complex conjugate roots? Instead of writing k1 plus k2, I'll write it as roots are k1 plus j into k2 d2 is equal to k1 minus j into k2. Those roots I'll write it in this equation. Instead of d square, instead of writing like d minus of k1 plus k2, here I'll write d minus of k1 plus j into k2, d minus of k1 minus j into k2 into I is equal to 0. That's what I've written here. For this, the solution is I is equal to, when you have a complex conjugate roots, the solution of this complex conjugate roots current response is e power k1 into t, e power k1 into t of c1 cos k2 into t plus c2 sin k2 into t. So the current response is I is equal to e power k1 into t of c1 cos k2 into t plus c2 sin k2 into t. If you see the current response, it will oscillate. Initially it will increase, then it will go to the minus. It will oscillate around the final response, that is 0. The current response I is, it will oscillate around the final response and later it will settle to the 0. The third case is if K2 is 0. When the K2 will be 0? K2 is equal to, if R by 2L square is equal to 1 by LC, then K2 is equal to 0. If K2 is equal to 0, only one term, that is D1 is equal to K1 and D2 is equal to also K1. That's what, when K2 is equal to 0, if K2 is equal to 0, when R by 2L square is equal to 1 by LC, the roots are real and equal. Both D1 is equal to K1, D2 is equal to K1 only. The roots are real and equal and gives the critically damped response as shown in the figure. We'll see that figure. So I can rewrite that equation as d minus k1 into d minus k2 into I is equal to 0. For this, the current response is, the solution of the current is I is equal to e power k1 into t. As two roots are repeated, we'll get the solution as c1 plus c2 into t. E power k1 into t, c1 plus c2 into t. The current solution is I is equal to I on y-axis, t on x-axis. It will increase and decrease, but it will decrease to 0 at early than the overdamped response. So this is all about the derivation of that DC response of series RLC circuit. Next we'll see the problem. The circuit shown in figure consists of resistance, inductance and capacitance in series with a 100 volts constant source. When the switch S is closed at t is equal to 0, find the current transient. So this is your circuit diagram. 100 volts is connected through the switch to series 20 ohms, 0.05 Henry and 20 microfarad RLC circuit. So the current response we need to find out. As a first step, if you find out these transient questions, the first step is apply KVL and find out the differential equation. By applying KVL, 100 volts is equal to 20 into I plus 0.05 into di by dt plus 1 by C, 1 by 20 into micro, 10 power minus 6 integration of I into dt. By differentiating the above equation, we will get differentiation of constant, that is 0, 20 into di by dt plus 0.05 into d square I by dt square plus I by 20 into 10 power minus 6. I can rewrite the same equation by dividing on both sides with 0.05, so that I'll get d square I by dt square plus 400 into di by dt plus 10 power 6 into I is equal to 0. I can rewrite the same equation for simplification. I'll assume d is equal to d by dt, so that I can write d square into I plus 400 into d capital Di plus 10 power 6 into I. I'll take common. So d square plus 400 into d plus 10 power 6 into I is equal to 0. If I find out the roots of this characteristic equation, thus in bracket, the d square plus 400 into d plus 10 power 6 is equal to 0 is called characteristic equation. If I find out the roots, d1 and d2 is equal to, it looks like ax square plus bx plus c, second order quadratic equation. The roots are minus b plus or minus under root of b square minus 4ac by 2a. Finally, you will get the roots as minus 200 plus or minus under root of 200 square minus 10 power 6 means. So here the first term is lesser than the second term. You will get the complex conjugate root. Inside you will get the negative term, that will give the j term, right? So d1 is equal to minus 200. One is plus j into 979.8. Another one is d2 is equal to minus 200 minus j into 979.8. If you have a complex conjugate roots, what is the solution? I is equal to e power k1 into t of c1 cos k2 into t plus c2 sin k2 into t. Here k1 k2 are, k1 is equal to minus 200 first term, k2 is equal to second term, 979.8 of the roots. I'll substitute this k1 and k2 in this above equation. I is equal to e power k1 minus 200 into t of c1 into cos k2, 979.8 into t plus c2 into sin k2 into t, sin 979.8 into t amperes. So we got the solution. This is your third equation. Sorry. Yeah, let us assume this is second equation. But here in the second equation, you have an arbitrary constant c1 and c2. If you find out the c1 and c2, that is the complete solution of the current. How to find out that c1 and c2? By using the initial conditions. At t is equal to 0, the switch is closed. As per the problem statement, the switch is closed at t is equal to 0. At t is equal to 0, when the switch is closed, the current flowing through the circuit is 0. Because what are the initial conditions? If you see the initial conditions, at t is equal to 0, we are closing the switch. But before that, the switch is open. That means at t is equal to 0 minus, at t is equal to 0 and t is equal to 0 plus are the transient conditions. At t is equal to 0 minus, that means earlier the switch is open. At t is equal to 0, the switch is closed. Further, the switch is in closed state only remains. That means at t is equal to 0 plus also the switch is closed. When switch is open initially, when it is open, simply the current flowing through this loop is 0. I is equal to 0 ampere. When current is 0, the voltage across capacitance. When current is 0, the voltage across capacitance also 0. Voltage across capacitance is 0. We need to consider the, because inductor do not allow the sudden change in current. That's why I am considering I. I is equal to IL. Single loop, that's why. And voltage across the capacitor, because capacitor do not allow the sudden change in voltage. Vc is equal to 0 volts. When the switch is open. At t is equal to 0, the switch is closed. When the switch is closed, the inductor and capacitor do not allow the sudden change in current and sudden change in voltage. That's why the same current will carry forward at t is equal to 0 and t is equal to 0 plus also. 0 current and 0 current. Vc is equal to 0 volts and 0 volts. Based on these initial conditions, if you draw the circuit diagram, the same circuit diagram, switch is closed, resistance, what will happen? The inductor current is 0, I is equal to IL. Inductor current is 0 means it is open circuit. Open circuit. And what about the capacitor voltage? 0. 0 means it is short circuit. This is short circuit, means it will directly go to the minus, and here plus will go to the, but the current flowing through this resistance is 0. That's why there is no drop across this resistance. Simply we can say that the voltage across inductance is equal to 100 volts. Plus will be at plus, minus is at minus, or if you apply KVL, you will get VL is equal to 100 volts. Now I will use these initial conditions. At t is equal to 0, I is equal to 0, right? Current response. At t is equal to 0, the current flowing through the circuit is 0. I of 0 is equal to 0. I'll substitute wherever t is there I'll substitute the 0. E power minus 200 into 0, C1 into cos 0, C2 into sin t, means here also 0. The sine term will become 0. Sine 0 means nothing but 0. Cos 0 is equal to 1. C1 e power 0 is equal to 1. So I of 0 is equal to 0. Initially the current is 0. So you will get the C1 as 0. This C1, if I substitute, C1 is equal to 0. If I substitute in the second equation, this first term will become 0. By substituting this, your current equation will become I is equal to C into e power minus 200 into t, only second term, into C2 sin 979.8 into t. So we need to find out that second arbitrary constant to get the final solution. This is the final equation. I is equals e power minus 200 into t, C2 into sin 979.8 into t amperes. Again, if I want to find out this C2 arbitrary constant, I need to use the another condition. To use that another condition, from the initial conditions, I got voltage across inductance is equal to 100. By short circuiting this capacitance, by open circuiting this inductor, because inductor will act like a open circuit in transient, capacitor will act like a short circuit. So the inductor voltage VL is equal to 100 volts, right? Out of this, so I'll use that VL is equal to di by dt. VL is equal to di by dt, which is equal to 100. I know the L value, so I can substitute di by dt is equal to 100 by L, and already I know the current equation. For that, I'll differentiate this equation. Di by dt is equal to, this is C2 is constant, I'll take it out of that differentiation. It is just like u and v, two terms are there, right? Differentiation of uv is nothing but u dash v plus u v dash. First I'm differentiating any one term, you can differentiate. I'm differentiating this sine term. U is as it is, e power minus 200 into t, and differentiation of this sine 979.8 is nothing but the t coefficient will come out of that, into differentiation of sine is cos 979.8 into t, plus differentiation of this first term, so minus 200 into e power minus 200 into t, again second term is as it is. I'll substitute t is equal to 0 in this equation, because the di by dt you will get the equation VL is equal to 100 volts at t is equal to 0 only. Again, if I substitute t is equal to 0, the voltage across inductor is 100 volts. This is what I've told. So the equation is like this. VL is equal to 100 volt. What is VL? VL is equal to L into di by dt. So if I want to know the only di by dt, I'll substitute this L value from the circuit diagram. L is equal to 0.05 Henry. 0.05 into di by dt is equal to 100. Out of that, di by dt is equal to 2000, because 100 by 0.05. At t is equal to 0, di by dt is equal to 200. di by dt, voltage across inductance is equal to, so 2000. At t is equal to 0, di by dt is equal to 2000. From this, I'll substitute t is equal to 0 in that above equation. If we substitute C2 into this e power 0, 979.8 into cos 0, e power 0 into minus 200 into sin 0. This second term will become 0. Cos 0 is equal to 1, e power 0 is equal to 1. C2 into 979.8 you will get it. C2 into 979.8 into cos 0 plus 0. Only C2 into 979.8 is equal to 200. Out of that, C2 is equal to, you will get it as 2.04. That if I substitute in the same equation, in the first equation C2, if I substitute in the third equation, this is third equation, let us say, then you'll get the current solution as I is equal to e power minus 200 into t, or 2.04 into e power minus 200 into t sine 979.8 into t. This is the final solution of the current for DC series circuit. Okay. This is all about the problem. Thank you all.